This illustration, let a and b and lambda be positive real numbers and p is the endpoint of lateral rectum of parabola this. Suppose ellipse this passes through p. If tangent and parabola and ellipse at p are perpendicular, then we have to find out the eccentricity of this ellipse. This is a very simple question, and let's draw it. The parabola equation we have. This is our parabola. Since lambda is positive, mentioned over here, and we have to draw this kind of parabola. So let's say this is the point lambda comma 0, because this is the focus of this parabola. Since y square equal to 4ax, here a is basically playing the role of lambda, so lambda comma 0 will be this point, and this will be the lattice rectum. So let's say p, in the first quadrant we have taken this p will be lambda comma, to find the y value, let's put x equal to lambda. We have 4 lambda square, so y equal to 2 lambda. So now if we draw the tangent at point p, we can write, let's differentiate it, y at 2y y dash equal to 4 lambda, and we have y dash equal to 4 lambda by 2y. So this is basically slope of the tangent. So at point p we have slope will be 4 lambda equal to 2 into y value will be 2 lambda. From this we get y dash equal to 1. So that means the slope of this tangent will be 1. Again, here the mentioned thing is the ellipse, this ellipse also passes through point p. So let's say the ellipse will be like this, and this passes through this point. So now to find the tangent at point p, we have tangent equation from x square by a square plus y square by b square equal to 1. To find the tangent equation, and we have the point p lambda comma 2 lambda. Let's do the t of xy equals to 0. We have the tangent equation will be lambda times x by a square plus 2 lambda y into b square equal to 1. To find the slope of this tangent, we have to find basically the y equal to mx plus c. We have to find m. To find m, we have m value will be lambda by a square with a negative sign, b square by 2 lambda. That means this will be lambda gets cancelled, we have minus of half of b square by a square. And now we have these tangents are perpendicular to each other. Here it is mentioned. To satisfying this condition, we have the perpendicular condition will be m1 m2 equal to minus 1. So let's put m1 equal to, let's say 1, into m2 will be minus of half b square by a square equal to minus 1. Minus gets cancelled out, and we have b square by a square value will be 2. Now we have to find out the eccentricity of this ellipse. So eccentricity of an ellipse will be 1 minus b square by a square. Here we assume that this ellipse is horizontal ellipse. So we have written over that b square minus a square, and observe that here b square minus b square by a square value is 2, which is greater than 1. So this cannot be a horizontal ellipse. So let's assume a square plus b square equal to half, and so we have a vertical ellipse like this. So now putting this value equal to 1 minus, for this vertical ellipse we have a square by b square, and putting this value half, we get 1 by root 2. So 1 by root 2 will be the final result of this problem. And here our assumption will be wrong, since this is an vertical ellipse, and this is clear from this value b square by a square. So 1 by root 2 will be the final result of this problem.